This is section 5.1 of the 2, page 315, operations with functions. And we begin with saying that we are going to do the 4 operations with functions. We are given that one function f of x equals x squared minus 4x, and g of x equals 2x plus 1. Given those 2 functions, to add functions, if we were to add the f function plus the g function of x, it's the same as taking the f function plus the g function. So quite quickly, it's taking x squared minus 4x plus 2x plus 1. So we get x squared minus 2x plus 1. It was noted that you could factor this possibly, but in this case you don't need to because we're just adding them together. Okay. So if there's an addition one, there's also a subtraction one, which means that I'm taking f of g minus x. Now this one's far more important which one you put first than the addition. On the addition, it doesn't matter which one you get in the right order, but in subtraction it does. So make sure that you get the correct one in the right order. So we would take the f function, which is x squared minus 4x, and we would subtract the 2x plus 1. Now you'll notice that in the addition that I did not put them in parentheses because it doesn't matter according to the commutative property of addition. We can add it in any order we want. However, subtraction is not that way. Okay, so it does matter the order, and we do have to subtract a quantity. Okay, so this is x squared plus a negative 4x plus a negative 1 times the quantity 2x plus 1, and I'm going to distribute the negative 1 through. So I have x squared plus a negative 4x plus a negative 2x plus a negative 1. And if I combine like terms, I get minus 6x minus 1, or plus a negative. It does not matter, but this is the subtraction of the 2. Did I do that right?
I think so. Can you have it plus and negative?
Yes, you can. I was just looking at theirs, and that's, oh, now I know why they didn't do that. Because I did it different. Well, if you can add and you can subtract, certainly you can multiply and divide. I'm going to choose 2 different functions just to add a little bit of difference. Given we're going to change f of x equals x squared plus 5x minus 2, and g of x equals 3x minus 2. Okay? So we're going to look at multiplication and division. You two might want to finish up. Okay, we've had a little bit overtime what I said. Okay, so the first thing we're going to do is we're going to multiply. All right? And so if we take f times g of x, this is the same as taking the f function times the g function. Just write out. Okay? We want to multiply the 2. So in order to do that, we have x squared plus 5x minus 2 times the quantity of 3x minus 2. From the last chapter, you remember that we can take each member of the binomial times each member of the trinomial. So it might be better if you change all subtraction here too. Okay, thank you, Connor. Would you warn her about it? Callie's ready to
Going
go.
for it.
All right, have a nice day. Remember, takes a big man to cry, but an even bigger man to laugh at. Right? All right, just remember that when I pass these out tomorrow. Okay. So if I take this, I get 3x cubed, and then I'm going to take it here, and I get plus 15x squared. I'm going to take it here, and I get plus a negative 6x. Whoa, I don't know what that means.
You sleep for us.
Sorry, the Greek language started to come out there. Callie, have a good one.
Yeah.
Okay, so then I'm going to take this. I don't think she was happy with that, but and then this, which is negative and this, which is 4. Okay, so I get 3x cubed plus, and this is like with this, 13x squared plus a negative 16x plus 4, is that correct?
How'd you get? Oh, I see it.
Like terms. All right, pretty good?
And that's your answer?
That's your answer. Okay, now, just like in life, division is always the bear cat, isn't it? It's the one that causes us usually the most pain. We're going to divide, if we divide f divided by g of x, this is f of x divided by g of x. Just the functions, okay? So here's where you might want to consider factoring. Okay? Just to see if the top would cancel with the bottom. If the top cannot be canceled, or cannot be
I
factored,
don't think it can be.
I don't think it can be in this case either. But you should always look to see if you could cancel a quantity. Yep.
Would the negative 2's be able to cancel out?
No.
Okay.
You have to cancel quantities,
Okay.
because they're separated by addition and subtraction.
So, like what?
What do you
What
mean?
would be
Like,
an example
if
of
you had
that?
3x minus 2 times 5x plus 2, up here the 3x minus 2 would cancel. Does that make sense? Or you want to see that?
Sure.
All right. So, say like you had 3x minus 2 times x plus 1 on top, and you had 3x minus 2 on bottom. This would cancel with that.
Okay.
That's all it has to cancel between multiplication. Okay? All right. So if you're looking at this, there's one thing you always got to be concerned with the denominator. This is not fun, but this cannot be 0. All right? So what you have to, why can't it be 0? You looked at me like,
Because it equals 0. Or
it
something.
cannot equal 0. You cannot have a value of x times 3, subtract 2, that equals 0. If you have a 0 in the denominator, it's undefined.
Oh.
So when we do operations of functions, we have to make sure that that is not the case. So we have to give instructions on what it can't be. So I have to set this equal to 0 and solve for x. And you get x equals 2/3. So off to the side, it's x. You had it equal to 2/3, right? But now you say it cannot be 2/3. Do you understand why?
Because it can't be 0.
It can't be 0. So if this was
Oh.
2/3, this would be 0, and you can't divide by 0. So by setting it equal to 0, we actually find what it can't be. Okay? You have to do that on all of those. Why? Because you don't want it to be 0. That's the operation. Okay? Questions?
Wait, so then, how do you solve it?
That's it?
That's your answer?
That's your answer.
You-
But this is included in your answer. It's part of your answer.
But that is the answer.
So your answer is.
This isn't the answer, but x cannot equal negative, equal positive 2/3.
Box the answer.
Okay.
Okay. So what about the top number? Like,
The what?
like the,
That doesn't matter if
It
that's
doesn't?
0. No, that can be 0 all you want.
okay.
Yep.
Alright.
Okay. All right. Now, let's look at it graphically. All right. The people on the video cannot see the reaction in the back, but there's a lot of no, let's not. But we are going to. Okay. So what we want to do is I want you to look at 2 graphs. Let's change f of x. F of x equals x squared. Let's keep it fairly simple. And then g of x equals x. Okay? Now, you may not remember that that is simple, but that is simple. The first one is a parabola, correct?
Yes.
Okay, and it looks like, you may have to turn this. The first one is a parabola that looks like, if you just graph, use the t-table, its vertex is at 0, 0, correct? and then you go 1 over 1 up, 1 over 1 up, 2 over 4 up. So it looks like this. Is that easy enough for you? All right. The second one's a line, y equals x, and the slope is 1 and the y-intercept is 0. So it actually goes through here and it is diagonal, right? So it looks like this. Okay? That makes sense? Okay, so what we're going to look at is we're going to look at f of x plus g of x graphically. So, okay. So you might make a chart, and let's just begin with a -3. So we would have an x is our -3, correct? And then we would have an f of x and a g of x. Correct? All right. And then the two put together. All right. So it would be f of x plus g of x. And actually that equals what? If I added these two together, what would it be?
X squared plus
Well,
x.
there you go. So we can just create a chart. All right. Tell me what the value is when I put -3 into f of x.
9.
9. And what is g of x?
-3.
-3. And what do we do with these two?
Add them.
Add them together.
So it's 6. It's not that difficult, is it?
No.
Okay, so let's try -2. It would be what? 4 plus -2, which is?
2.
And then we would do a -1, which is?
1, -1.
Be
0.
1, -1 is 0.
0.
Is that right?
Yep.
And then what is 0?
0.
Zero's
0.
all the way.
0. 0.
All the way? Okay. If you can tell how I get these on page 316, they have these values. Okay? So let's graph them.
Okay.
I'm going to graph them in a different color so you can kind of tell. A -3 what? 6? A -2 what?
2.
-1,
0.
0, 0,
Yep.
right? What did we get for 1? We didn't put 1 in.
It would be 2,
It would be 2. You see what's happening?
and then 2, 6.
2, 6.
So when you graph it, you take the values under the x column and the values under the x squared plus x column. So like -3, 6.
I see what you're saying. So, yeah, so what I'm doing is I'm graphing this and this, this and this, okay, as ordered pairs, right? Okay. What did you say 1 was again?
2.
1 is 2?
Yeah.
Okay, so what you get is, it's a parabola that looks like this, okay? And it has its middle right there, but that is the addition of the 2. It wasn't a very good graph, and hopefully you can see it on the video, but it is green, it goes right here, okay? But you see how easy it is to put the 2 together, okay? But you do kind of have to create a chart, because you can get kind of caught up in, you know, is this right or is this wrong?
How did you guys get the g of x again? Like,
You just put it in, put the number in to
Yeah.
g of x.
oh,
So -3 is -3.
okay, I was like, what are you multiplying? That does not make sense.
Okay? All right, let's take a look at the exercises then. Okay. The first, we're going to do evens, 4 through 32 even. It says find the addition f of g, f minus g, f times g, and f divided by g for each of f of x and g of x. Indicate any restrictions on the domain. Okay, let's take a look at 10, shall we? f of x equals
A negative x squared plus 6.
and then g of x equals,
2x squared plus 3x minus 5.
thank you. Okay. All right. So let's do addition first. That's adding the two together, so I have a negative x squared plus 6 plus 2x squared plus 3x minus 5 plus a negative. So a negative x squared plus 2x squared is a positive x squared, right? And then plus 3x. Try to write it in decreasing order for the polar soul that has to correct it. Okay? Which may be me. Alright? Or you. Now let's subtract it. It says f of g of x. Now remember that f subtract g is a lot different than g subtract x. Okay? Makes a difference. So we're going to take a negative x squared plus 6. We're going to take that quantity. We're going to subtract all of this quantity. Correct?
Yep.
So we have a negative x squared plus 6 plus a negative 1 times the quantity. I just always do that. Okay? And then we're going to bring that negative 1 through. Make sure you bring it to everything. And then do your like terms. This is like with this. No, this is like with this. And then 3x and 11, is it?
Yep.
Am I going too fast?
Nope.
Okay. Then we have times. A binomial times a trinomial. So this, which is a negative 2x to the 4th, is that right?
Mm-hmm.
Yep.
And then plus a negative 3x squared plus positive 5x squared, right? Plus,
The
The
3x is cubed.
thank you. $12x squared plus 18x plus a negative 30, is that correct? Now it looks like negative 2x to the 4th plus a negative 3x cubed plus 17x squared plus 18x plus a negative 30, is that correct? Is that what it looks like to you? Maybe we better check her. What number is this?
10.
Negative 2x to the 4th minus 3x cubed plus 17x squared, plus 18x plus negative 30. And we still have division, correct? Okay. So division is f divided by g of x, which equals a negative x squared plus 6, which is not factorable, over 2x squared plus 3x minus 5. Would you look to factor that? If we can't factor it, guys, guess what?
It's
We have to use the quadratic formula. So let's look really hard at factoring it, shall we?
Yeah, you can.
I think you can.
Can't you
Yeah.
multiply like the 5 by 1 and the 1 by 2?
I'm thinking 2x minus 5 and x plus 1. Let's try it. Minus 5.
Did you?
Oh,
Wow.
close. Plus 5 minus 1. Is that right?
Yes.
Let's see, that's be 5x and negative 2x is 3x. Good.
Wow.
All right, so that really helps us because now we can we can't cancel anything, but we can now tell you what the denominator is.
So you're always looking to factor the dividend
Yes.
or denominator.
Denominator, let's go with that.
So then you set them both to equal 0?
Yes, you have to set them both equal. I'm gonna do them one at a time. Bless you.
Oh.
And then, so, my two answers are, or excuse me, my two that cannot be used is x is not equal to the -5 halves, and x does not equal 1. I will put a box around my answer, so you know. All right. Let's take a look on page 319. Page 319 on directions for 18 through 25. It says use the table to find each value. Okay, let's look at 25. I know it's not an even, but it will help us. G over h of a -5. You see the chart there?
Yeah.
See the chart right here. Okay, so we're going to use that chart, correct?
Yeah.
All right, the first thing we're going to do is we're going to take g of a -5 and we're going to divide by h of a -5. What is g of a -5 equal? Well, in the column, you find x of a -5, and what is the g of it?
8.
8. And then you find the -5 and you find the h. Is there an h?
2.
Oh, clear down, yeah, 2. So you divide by 2, what? Show her.
Oh, okay.
You got it? So we're going to take the
So it equals 4?
g function, which is 8, and of a -5, and the h function of -5 of 2. So 8 divided by 2 is
4.
4.
And that's it?
That's it.
Huh.
Now let's take 31. Okay, it says if f of x equals a -x plus 1, g of x equals 4x plus 2, and h of x equals x squared minus 1, find each value. 31 says,
Parentheses 3f plus 2h parentheses
0?
0.
All right. Guys, if I were you, I would do this first. Okay. So I would take 3 times the f function and add it to 2 times the h function, and then at the end put 0 in. Okay? So this is what I mean, Lila. 3 times the f function is -3 times -x plus 1, correct? Plus 2 times the h function is 2 times x squared minus 1, correct? Sophia, you understand? All right, so then I distribute through, I have a -3x plus 3 plus 2x squared minus 1. And I'm going to write it in decreasing order. So
Minus 2.
minus 2, thank you. 2x squared plus a -3x plus 1, correct?
Mm-hmm.
Now, I'm going to put 0 in. So that's 0, 0, 1.
So your
My
answer
answer is
is
1. Yep. See how that works? Okay? So I think it's very important on those last ones to go ahead and do the operations with the functions and then put the value in. Okay? Questions? Comments?
When is it due?
Is due Monday.
Monday.
So your assignment is page 318, 318, 4 through 30 even. Is that what I said before? Let me check the board. Yep, that is due Monday. Okay.
Oh, there's gonna be